So, the next section in this statistics review is on regression. And there's so much that you can do with regression in so many different ways. I've decided to break this down into three separate videos. So, in this first video, I'm going to introduce regression and I'm going to cover simple linear regression. Then I'll have another video showing multiple regression, and then a third video showing multiple regression with categorical data. So, first of all, regression. What is a regression? So, with a regression, the big thing to know is here we are predicting. We are actually predicting an outcome variable. So, you're going to have at least an independent variable and a dependent variable. So, for a basic regression, traditionally, your independent variable and your dependent variables are at least at the ordinal level, typically even the interval or ratio level. It's quantitative data, that can start at 0 to infinity or even 1 to 5, um, that type of data. It's not traditionally categorical data, but we'll cover how you can conduct a regression with categorical data as well. Now here, the regression is telling you if your independent variable actually affects your dependent variable, and is there a positive or a negative relationship. It would tell you if there's no relationship at all, on the other hand. You will get a line equation. So you might remember from high school, y equals mx plus b. You will get a line equation from your regression that will allow you to actually predict your outcome variable using a certain value of your IV. So a regression is used for prediction and sometimes forecasting as well, and just to figure out, is there a relationship between a predictor and an outcome? So, like I said, there are various types of regressions. If you Googled various types of regressions, like literally that term, various types of regressions, put that in a Google search, and you're going to get a long list. There are many different types of regressions that can be used with different scenarios, multiple predictors, multiple outcomes, different types of data. Different regressions are appropriate. These are three that we're going to cover. So a simple linear regression, this is used when you have one independent variable and one outcome variable. A multiple regression is used when you have more than one independent variable, but still just one outcome variable. Now, there is a process called dummy coding that you would use if you have a categorical predictor. For instance, department in an organization or function in an organization. There are different departments like marketing, sales, finance, HR, whatever, IT, whatever. A variable like that is categorical, but you can change that variable through this process called dummy coding and include it as predictors in a multiple regression, if you wanted to see if that categorical variable predicted your outcome variable. And essentially what you're doing is you're creating a new column in your data set for each category. So for instance, I'd create a new column for sales, a new column for marketing, a new column for HR, etc. And then for each line under that column, if that case, person, or whatever it is you're talking about, if that case fell into that group, that category, you're going to give them a 1. If it did not, you're going to give them a 0. That's dummy coding, which I'll show you in the next couple of videos. Logistic regression, we're not going to get into that too much at this point. It might come up in a project, but just know that a logistic regression is used if your outcome variable is like a yes or no type of situation. So if, say, training attendance was your outcome variable and they either did attend or they did not attend, you could use a logistic regression to test that. Or getting a promotion. They got a promotion, yes, or they did not get a promotion. if a variable like that is your outcome, you're going to do a logistic regression. A few values that you're going to look for in a regression output, your coefficients, which are the values that go into that line equation that I was talking about that allows you to predict your outcome variable. You're going to have p-values, which we'll talk about, and you're going to have an r-squared value, which we'll talk about in a bit. There are a few assumptions with regression. With the types of regressions we're going to cover, we're only testing linear relationships. So that means that as one variable increases, the other one does as well across the board, or as one increases, the other one decreases as well across the board. The relationship doesn't change throughout, if that makes sense. It doesn't change from a positive to a negative relationship as you go along. Normal distributions, remember that bell-shaped curve. Your variables need to fall on a bell-shaped curve. They need to have that normal distribution, or at least something close to it. And multicollinearity is another thing to look out for. This multicollinearity is whenever your predictors are very strongly related. And when that is the case, it can be difficult to decipher which predictor is actually affecting the outcome variable. So if your predictors are very highly correlated, you might want to consider removing one from your model. A few examples of regression. So you could answer this question: does hours spent studying affect GPA? You could answer that with a simple linear regression because you have one independent variable, which is hours spent studying, and you have one dependent variable, which is GPA. This next business question: does years of experience in a sales role predict the amount of sales? That would also be tested using just a simple linear regression because you have one independent variable, which is years of experience, and one dependent variable, which is amount of sales. Lastly, the question: do hours spent working and insufficient resources affect stress level? This here would be tested with a multiple regression because you have two independent variables: hours spent working and insufficient resources. You have one dependent variable, which is stress level. So that is kind of the basics on regression. Now let's talk about how to run a regression in Excel. So these are the steps I'm about to show you in Excel. Note you cannot have any missing data or you will get an error. So keep that in mind. We are going to run a regression using a data set that I have posted on Canvas called Data for Excel Data Analysis Tutorial. And we're going to use care about me as a person as the predictor of happy. So I'm going to open up this data set and you'll see this is our data here. Care about me as a person is column E. Happy is column F. So one thing to note, you do have to have the data analysis tool pack included in Excel. And to get that, go to the data tab. You should see a data analysis button over here. If you don't have it, go to File, Options, Add-ins. Click this Go button and make sure Analysis Tool Pack is checked and click OK. And then it should appear up here. If it doesn't, close out Excel, reopen it, try it again. So I'm going to click Data Analysis Regression, click OK. Your Y range is going to be your outcome variable. So happy in this case. You're going to click the label at the top, happy, and then all the way down to the very last data point. Then for your X range, that's going to be your predictor. So care about me as a person, I'm going to click the label at the top all the way down to the very bottom data point. Check this labels box here since we highlighted our labels at the top of each column, Excel knows that that's actually a label and not a data point. And then click OK. So this is what you should get. And you will see images of this in my PowerPoint slides, which I'll walk you through. Now at this point, you might want to pause this video and go and do those steps and make sure you get the same thing as me. One thing to note, if you have any missing data in your variables you highlighted, you're going to get an error. So you need to just delete that row altogether. Okay, so here's our output. A few things I want to point out to you. Your multiple R at the top, that's your correlation coefficient. Your R squared here, that is your coefficient of determination, is what it's called. This tells you the percent of variation of your dependent variable that is explained by your independent variable. So happiness is our dependent variable. Cares about me as a person explains a very, very small amount of happiness, a very, very small percentage of happiness. Notice this R squared, 2.88, has an e to the negative 5 behind it. That means you move your decimal place to the left 5 times. So it's 0.0000288. So care about me as a person pretty much explains 0% of happiness. Now, observations, this here, the 693, that's your sample size. So it's how many rows did you have in your data set. This next table over here, some of this you're going to have to pull for writing your results. So just note your degrees of freedom, DF, is 1,691. I'll show you where you need to put that when you write up your results of a regression in a couple of slides from now. Then you have your F test statistic, which is under F, and your significance F, which is your p-value, 0.89 if we're rounding here. Now we're going to review what that p-value tells us. This is from QBA 283. If your p-value is less than 0.05, that is a sign that there is a relationship. So it tells you that the independent variable actually predicts your dependent variable. In this case, though, this p-value is more than 0.05. So that is telling us that our independent variable does not predict our dependent variable. So this report tells us how well the regression line fits the data or how well the regression model predicts the dependent variable. So this is telling us it does not predict the dependent variable well at all. Now in this bottom table, your t-test statistic and your p-value, that's another test that is going to test the same thing. It's going to test if your independent variable actually predicts your dependent variable. For a simple linear regression, you're going to get the same exact p-value. Let me move this little box out of the way. So notice this, it's the second value under p-value. That is the same thing as this. The t-test and the f-test are going to tell you the same conclusion for a simple linear regression. It's different with a multiple regression, which we'll talk about in the next video. So the coefficients are the last thing I want to show you. This is our line equation right here. Y equals the BO, that's your y-intercept, plus the B1, that's your slope, times x. Now, x is your independent variable, y is your dependent variable. Make sure you know that. You're plugging in those numbers into that line equation. So intercept, that's your y-intercept, that's 4.68. So I have 4.68 plugged in here, plus your slope, that's 0.01. I have 0.01 here, times x. So first of all, if there would have been a significant relationship here, if these p-values would have been less than 0.05, it would make sense to use this equation to predict happiness. So we could put in a value of x here, do the math, simple math here, and predict our dependent variable. However, here it doesn't really make sense to use this line equation because our significance test told us there's no relationship. But like I said, if there would have been a relationship, then this equation here would have been very useful at predicting our outcome variable. Okay, so let's talk a little more about p-values. What the heck is a p-value? I know you heard it over and over and over again in QBA 283, but it's one of those things sometimes, it takes a bit for it to stick. The big rule that you want to remember is in red here. If your p-value is less than alpha, which is usually 0.05, you're going to conclude there is a significant relationship. If the p-value is more than alpha, you're going to conclude there is not a significant relationship. That is the big rule of thumb. Now, if you want a little more information on what this means, this is relevant for all statistical tests. It just looks a little different. But for a regression, this was our set of hypotheses here that we're testing. Now let me refresh your memory on what this hypothesis tells us. The null hypothesis is telling us that the slope, the population slope, is equal to 0. Look at this image on the bottom right. That's what would happen if our slope was 0. Remember, x is along this axis, our independent variable. Y is along this axis, our dependent variable. If the slope is equal to 0, there's no relationship between the two. As x increases, y doesn't change. So our null hypothesis tells us there is no relationship. Our alternative hypothesis tells us the slope is not equal to 0. So it could be positive, moving upward. It could be negative, moving downward. The t-test and the f-test test this. Okay, so the t-test and the f-test tell you the same thing for a simple linear regression. So if our p-value is less than alpha, we reject the null hypothesis and we conclude the alternative. There is a relationship. If our p-value is more than alpha, we do the opposite. Okay, we conclude the null and we say there's no relationship. So I also wanted to kind of draw out a distribution for you. Remember this wonderful bell-shaped distribution. Another way of thinking about this, we are testing. Let me see if I can get my pen looking a little better. We are testing if the slope is equal to 0. We're going to have the slope of 0 right in the center of this distribution. If our alpha is 0.05, then we're looking at these two tails out here, 0.025 and 0.025 in each tail. That adds up to 0.05. We want to know if our p-value is less than 0.05, it's somewhere out here. That's very far away from 0. So we're going to conclude the slope is not equal to 0. But in the center, we have 0.95 if alpha is 0.05. Remember, everything under the curve must add up to 1.0. So if our p-value, our significance, is more than 0.05, we're somewhere in this vicinity where the slope is 0. So we're going to conclude the slope is equal to 0 and there's no relationship. So hopefully that's a quick little refresher from QBA 283 on p-values. That concludes the video on simple linear regressions. In the next video, we are going to cover multiple regression.